Hello, welcome. I'm just gonna wait just a minute so folks can come in and then we'll get started. So just wait about a minute or two. Thanks. Okay, I'm gonna go ahead. Good afternoon. Thank you for joining us. My name is Linnea Bond, and my colleague Chris is joining me today. We're speaking on behalf of Physicians for Social Responsibility Pennsylvania, a nonprofit made up of physicians, nurses, and other medical and health professionals concerned with preventing threats to human health that cannot be treated. We learn from and partner with residents across Pennsylvania, particularly in communities that are connected to proposed hydrogen infrastructure, and recently helped edit the 9th compendium of research on the harms of fracking and associated oil and gas infrastructure. Let me get this presentation up. There we go. All right. So a story first. In 2020, I found out that I had a tumor on my brainstem caused by a genetic abnormality. When I asked my doctor about my options, he said, "I'm a surgeon, so I always want to do surgery." There was significant risk in that surgery because the tumor was wrapped around my cranial nerves. I saw another doctor who did blood tests that the first doctor had refused to do. This second doctor found a second tumor behind my heart. And then after I had open chest surgery, he suggested targeted radiation on my brainstem because of the risk of surgery. I tell this story because to me, hydrogen is like an extreme medical intervention. Hydrogen is a potential tool in the climate emergency, but the risks of misusing that tool in the wrong circumstances are great. With $2 billion in grants for 2 hydrogen hubs that would mean building infrastructure across Pennsylvania, the stakes could not be higher for our state. If producing hydrogen is designed poorly and if it's deployed in the wrong areas, this growing industry will actually severely exacerbate our climate emergency, wasting billions of dollars in taxpayers and ratepayer dollars, while increasing mortality, morbidity, and environmental degradation in communities across Pennsylvania. Like cutting into a skull, we won't be able to go back and fix our mistakes. Today, we want to talk about why blending hydrogen and gas pipes is doing the wrong surgery, but how thankfully there are other and better ways to decarbonize heating in the face of our climate crisis. Because hydrogen barely exists in pure form, to use hydrogen, we need to take a compound containing hydrogen, that is, we need a feedstock, and we need to split the compound to separate the hydrogen. That process uses significant energy and requires significant new infrastructure. After that, we're also left with byproducts. Most people here are probably familiar with the colors of hydrogen, which describe the energy and feedstock of the process, like green hydrogen, which uses water as a feedstock, is powered by renewable energy, and splits hydrogen, H2O, apart into hydrogen for use and oxygen as a byproduct. Unfortunately, less than 1% of the US hydrogen is green. 99% of available hydrogen in the US comes from fossil fuels. For example, brown hydrogen is produced from coal as a feedstock. Every ton of brown hydrogen produced emits 10 to 12 tons of CO2. Brown hydrogen is an obvious backward step toward more climate warming and pollution. We also have hydrogen made from methane, which is gray and blue hydrogen. Whenever we use natural gas, for example, this Mark West compressor station and this gas-powered plant in Luzerne County shown here, we have a percentage of methane that leaks and also methane that is released intentionally. Methane leaks throughout the system from extraction to processing to transit to use. At least 1% of total natural gas production, or 6.5 million metric tons, leaks every year from our gas infrastructure, with estimates up to 9% from a Stanford study of New Mexico production. Over the first 20 years of it being released into the atmosphere, methane traps 80 times more heat than carbon dioxide. That is, releasing 1 ton of carbon dioxide into the atmosphere is like a single ton of blankets on our warming planet. And releasing the same amount of methane is like 80 tons of blankets. Studies suggest that although gas burns cleaner than coal, due to the prevalence of methane leaks, it has contributed to the same amount of climate warming. Using methane for hydrogen would increase these leaks with the increased demand for methane. But using methane for hydrogen production also needs to take into account the byproduct of CO2 after the hydrogen is separated. While the gas industry does not have a solution for their methane leak problem, they're proposing one for the CO2 byproduct issue, carbon capture and sequestration. But carbon capture sequestration fails at scale again and again. The S&P Global has reported that the US Energy Department had spent nearly $700 million on unsuccessful demonstrations of carbon capture and sequestration by 2021. But with the orphan and abandoned well problem in Pennsylvania, carbon capture in our state is additionally risky. The DEP has documented that about 27,000 of these wells, the DEP has documented about 27,000 of these wells and investigated about, orphan and abandoned wells, The DEP has documented about 27,000 of these orphan and abandoned wells and investigated about 8,500. The governor's office has stated that these wells make up 8% of our state's methane emissions. But this year we plugged 100 of these wells out of 27,000. And keep in mind that these plugs don't last forever, so they need to be redone regularly, forever. And this is a growing problem. Not all of these historic wells are like the ones pictured here, were drilled before regulations took effect. A report from the DEP released at the end of last year said investigators found more than 3,000 newly abandoned wells over the 5-year review period. Injecting carbon into the earth with Pennsylvania's significant unplugged well problem risks explosions and water and soil contamination. It also replicates the same challenges we're facing today with the problem of plugging these abandoned wells. We would need to store this carbon eternally. Put each part of this picture together and compare it to the findings of the scientific community, and the result is not at all that surprising. Blue hydrogen, studies are showing that blue hydrogen is less efficient than just burning natural gas. Additionally, like methane, but even more so because of its small molecular size, hydrogen is prone to leaking across its long value chain, shown here along the bottom of the slide. When it leaks, or when it's intentionally purged as part of the industrial process, it reacts with naturally occurring hydroxyl radical so that methane can't. Hydroxyl radical is methane's primary sink or neutralizer. So more hydrogen in the atmosphere means less OH available. Thus, more of this extremely potent greenhouse gas methane stays in the atmosphere longer. It also enables the formation of tropospheric ozone, which is another greenhouse gas. Thus, researchers like Alyssa Oko and Stephen Hamburg, who published this infographic last year as part of their paper, Climate Consequences of Hydrogen Emissions, call it an indirect greenhouse gas. Thus, as fossil fuels produce carbon dioxide and increase atmospheric methane, we must produce and use only hydrogen that does not rely on fossil fuels. Therefore, we need to be producing and using exclusively green hydrogen. But green hydrogen is such a small amount of hydrogen available and takes such a huge amount of water and energy to make that we have to only use it for areas that are the hardest to otherwise decarbonize. And we have to minimize the possibility of it leaking and adding to warming. Additionally, in 2020, the US used 11.3 million tons of hydrogen per year, which again was 99% non-green hydrogen. So that all needs to be replaced by any new green hydrogen as well. So what are areas that are hard to decarbonize and what are comparatively easier? This is Michael Liebreich, an independent analyst and advisor and a pro-business supporter of the UK Conservative Party, who sits on the British Government Board of Trade, and he is also an advisor to Norwegian oil giant Equinor. He created this ladder, and actually there is a more recent ladder that was recently released, and I'm sorry that that has not been updated in the slide, but the relevant areas are actually lower toward the bottom now. He created this ladder with the hardest to decarbonize industries to make sustainable or power any other way than hydrogen at the top of the ladder. And at the bottom are the areas where there are better, cleaner, and more efficient solutions than both fossil fuels and hydrogen. Those he calls uncompetitive. You'll notice that he suggests hydrogen should be reserved first for agriculture and some chemical production and steel. On the uncompetitive end, that is areas that we should not use hydrogen as an end use because there are better ways to decarbonize the industry. We have commercial heating and industrial heat, and toward the very bottom, we have domestic heat. Again, that's still true in the newer version. What do we mean by domestic heating? We're seeing proposals, largely from utility companies, to mix hydrogen with methane and pipe the mixture into our homes, where we would burn this mixture in our gas-burning furnaces, stoves, and other appliances. This is sometimes referred to as hydrogen blending or high blend. Private utility companies and the Department of Energy are doing research into hydrogen blending, with the Department of Energy's October 22 findings showing a multitude of technical challenges. So let's look at why Michael Liebreich, as well as a multitude of other analysts, scientists, and climate researchers, think this is a bad use of an expensive resource. Blending hydrogen for residential heating is a bad idea because our system is already dangerous. Hydrogen causes breaks in pipes because of embrittlement. It's a climate backstep, investing us in a heavy greenhouse gas system with only tiny savings in greenhouse gases. It delays the better, cheaper, tested solution of electrification, and it's expensive for customers, many of whom are already financially burdened by energy bills. Gas, for example, in stoves, in pipes is already dangerous. Gas stoves are dangerous, which helps us understand not just stove hydrogen and gas blending, but the explosive and pollution risks of all hydrogen blends. Oh, I believe these are your slides, Chris. Sorry.
Hello, everybody. I'm Chris DiGiulio. I'm the environmental chemist for Physicians for Social Responsibility. And of course, I'm going to be talking as a certified thermographer with optical gas imaging. You can go to the next slide. So it's already dangerous. So one of the things that I do is obviously as a direct service, we've actually gone out to places like Plum Borough after houses have had neighborhoods have had an experience of a failure of natural gas, and it ends up causing an explosion, ignition, and a lot of homes and people and lives were lost. And so I went out and started imaging just to inspect their homes. And when I went there, I started looking at the gas stoves. Now, this is where the hydrogen blending of already a very dangerous and interesting thing. Basically, we have our natural gas stoves in our homes, and we all have a fume hood above our stove. It could be like your microwave. It's usually a microwave, and those microwaves are like recirculating air, and they're not removing the air out of your home and taking it outside of your home. What it is doing is just kind of moving it. And when you have natural gas, which has, as we know in the OGI world, there's a lack of combustion a lot of times, and so you have actually resulting like the hydrocarbons escaping, and that means it's just recirculating and combining into your home if there's no fume hood that takes it outside of your home. So your fume hood, if you have natural gas stoves, frac gas stoves, I'll say what it is, should be vented outside of your house and have enough power to draw. So there's a wonderful publication from the PSR our national group, and from Health Effects, which is you can see it right here. When you blend hydrogen into something that already has lack of regulation, lack of home safety, in my opinion, what happens when you put hydrogen into that stream, which is it's a smaller molecule. It's also, it could cause explosions and combustion a lot more. Can you go to the next slide? Because I'm going to show you exactly what I found when I went to people's houses in the stoves and looked at image stoves. So if you press play, I'll try to walk you through this as best as possible. So I'm showing you just what it looks like with your, the visible spectrum. And as you see the blue flame, blue is showing, it's a good thing. When you see the orange, it's not fully burning. And this is, when I move to this, I'm just showing you basically what happens when you are looking at a stove. There you go. And now when we use the FLIR optical gas imaging camera, you're going to see what we, so this is the ignition. And, the thing that you're seeing above that, so there's a heat source where it's really bright white. That's like showing the thermal heat source. But what is going on above this is an improperly vented. It's just like one of those microwaves, and you can see that the smoke, that's not smoke. That is actually hydrocarbons that are not fully combusted. And this is called high sensitivity mode in the camera. And you can kind of see how it's hitting the fume hood or the vent, whatever. And it actually travels up and moves across the ceiling. I've even seen it going across the ceiling. And I'm going to show another a version of this at another stove that has an actually properly vented stove. And this is actually I was turning, this is when I turned it off. They turned it off and it was still emitting. As you can see, it's still emitting the gas. And that is going into your atmosphere. And as you saw with the health impacts and the dangerous chemicals in it, you can only assume you want this stuff to be vented out of your house. Opening a window is not sufficient. You need it to be directly vented. So, and you can see the white, that's heat source. That's actually the thermal signature. And we're going to move on to another. This is an efficient one. It takes a little bit to focus. All right, so we're in it's a different, it's the reason why it's black is because I inverted the polarity to see it easier. And so you're seeing, again, the dark is actually showing thermal, but you'll see like a smoky, as soon as I move up, yeah, you'll see this is again high sensitivity mode. That's your thermal signature. But when you go up, you can actually see, of course, it's not being fully combusted. I don't expect it to. And this hood actually is sucking it in and it's taking it out of the house. I didn't know this when I was imaging it. This was kind of an interesting project. I just was showing people what their like I was actually just inspecting their homes, and when I went to the stove to inspect it, I asked them to turn it on, and I saw this, and this one gentleman had it properly, vented stove. And I did, that was the first one I actually went to. And then the second one, and actually everyone after that had improperly vented, stoves. And I was completely surprised as when I started looking at the uncombusted hydrocarbons, they were actually like moving up around the microwave or whatever, and then up on the ceiling. You could just see them like kind of skirting across the ceiling, which was like quite scary to me. For the fact of like our homes have enough emissions in sense of air quality that this is adding to it and it's not leaving the home. People say open your windows. That's not going to actually be sufficient because it's already up. It rises. It's a lighter molecule, so it's rising up. Your windows are probably lower. So, I mean, unless you have a fan or something that's sucking it out, you're going to have that accumulating in your home. So, next slide. And just to address also, when we are doing hydrogen blending, we have to think, as Linnea was making a mention of, the hydrogen embrittlement. We know this in pipeline world with the cathodic protection. Hydrogen embrittlement is actually a result of lack of cathodic protection, and it's basically causing the metals to get harder and stiffer. And so, embrittlement means it's like easier to snap. It doesn't have the malleability anymore. And what's really bad about us adding hydrogen in regards to stoves, for example, we know that these stoves are rated to be able to handle that extra chemical stress on it. So like even your own home appliances, they'd have to put coatings on a lot of things, because hydrogen being it's the smallest molecule on the periodic table, it can go through, metal, and we're talking about like anybody who has a stove, if they switch, or if they don't necessarily have to tell us, from what we understand, that they're switching and blending, do the appliances in your home actually, like, whose liability is that, and can they handle it, and what effects or impacts will it have on the ability for them to operate as they're supposed to, within their parameters or within their specs. So I just wanted to show you guys visually what I have seen, and I really appreciate it. I'm going to hand it back off to Linnea. She's doing a fantastic job. Thank you for your time, everybody.
As Chris mentioned, hydrogen is the smallest molecule in the universe, which creates pipeline integrity and leakage challenges throughout the existing U.S. natural gas infrastructure system. Nearly all transmission pipelines are made of high-grade steel and transport gas at high pressures. Under these conditions, hydrogen can exacerbate pipeline cracks and cause embrittlement, increasing leakage and explosion risks. Even in plastic gas distribution mains and service lines, every point of connection provides an opportunity for gases to leak, which is a problem we already see with methane. Because of hydrogen's small size, that leakage risk is greatly increased. But in Philadelphia, where I live, our gas infrastructure is old and still significantly cast iron. More than half of our pipes are at risk. This means that many of our pipes are already leaking. In 2019 and 21, these leaks led to explosions in South Philadelphia that destroyed 6 homes. When we talk about current research, I want to underscore again that Pennsylvanian pipes are not Californian pipes under lab conditions, but to take the research we have available with these conditions that are far better than ours, Californian studies have only allowed up to a 20% blend of hydrogen into pipes without an entire overhaul of the gas system. With that 20% blend, gas utilities can only achieve a mere 6 to 7% reduction in greenhouse gas emissions, because hydrogen molecules produce less energy than methane when burned. 20% hydrogen blend would provide only 6 to 7% of the mixture's energy content. And keeping in mind that 6 to 7% does not include whatever savings would be lost depending on the method used to produce that hydrogen. And the remainder of the blend is still methane. So after all these upgrades are complete and millions of dollars have been spent, we've not solved the problem that we are burning fossil fuels and continuing to warm our planet, increasing flooding across Pennsylvania, droughts across the world, forest fires in our carbon sinks, farms, and communities. Hydrogen blending is a climate backstep. So why, in the face of all these realities, are gas utilities pushing hydrogen blending so aggressively? Michael Liebrecht says, if you're an oil and gas company, talking about hydrogen is kind of a two-way bet, because if it works, then you're embedded in the hydrogen industry. But if it doesn't work, you've delayed the transition to the thing you don't make, which is electricity. So why wouldn't you promote hydrogen for inappropriate use? Because it creates confusion, which is great for them. They want to get us locked into using their gas pipes for decarbonization because that's their asset, end quote. This industry has an enormous financial incentive to promote this technology, regardless of whether it's appropriate to do so. The fact that they are leading this push is foundationally concerning. Finally, hydrogen blending is prohibitively expensive. According to the final report published by the University of California to the Public Utility Commission, major modifications of end-use equipment and appliances would be required to differences in the combustion of hydrogen gas, and also the existing standards and regulations for fuel requirements. Due to strict requirements on gas turbines, on fuel specifications, end-use equipment could be the limiting factor of maximum concentration of hydrogen blending in the natural gas infrastructure without any major modification, end quote. Hydrogen blending would require extensive upgrades to our gas system, locking us further into methane. But there are also gas pipes throughout homes and buildings that would likely need to be upgraded in addition to our gas appliances. So customers would need to buy gas-appropriate appliances instead of replacing them with electric appliances, like far more efficient heat pumps, and induction stoves that can be powered by renewable energy sources. Finally, continued reliance on methane creates local pollution and soil and water contamination from fracking for oil and gas. While impacts to our water, air, and soil ultimately affect everyone, low-income communities, communities of color, rural and indigenous communities suffer disproportionately from fracking-related harms. Hydrogen blending with methane and hydrogen produced from methane means more of the same. And production of hydrogen from methane is itself a toxic industrial process that is more than likely going to increase pollution within our environmental justice communities. Blending hydrogen in pipes is not recommended by energy experts for the reasons I've outlined. It's not a plausible solution to our climate problem when we are looking at how to eliminate fossil fuels, especially from our domestic heating systems. But the good news is that we don't need to blend hydrogen into our gas systems to lower our greenhouse gas emissions. We have a better, safer, ready solution in electrification. There's even pilot projects in process, like Philadelphia Energy Authority's Built to Last program, that are combining energy efficiency efforts with electrification and solar, where possible, to study how we can deploy these solutions equitably, centering justice for vulnerable populations and solving multiple problems in one effort. We can save money by investing in our tested electric solutions rather than continuing to waste money on testing solutions we can already see work against our goals, like blending hydrogen into our fossil fuel-based heating. Hydrogen that is made without fossil fuels may be a key in essential industries like agriculture or steel, but hydrogen is a precious resource because it's costly to make along multiple metrics, from health to energy. And like invasive surgery, hydrogen is dangerous to deploy in every instance where we currently use fossil fuels. So let's suit the intervention to the issue, not the other way around. Yeah. Does anyone have any questions? And I believe we have our executive director looking.
Yes. Hi. You do have a few questions. So the first, we have someone asking if you know whether or not Pennsylvania landlords are required to provide some sort of hood or vent for gas stoves.
They are not. I don't have a hood on my house. I am a renter and I have a gas stove.
I'd love to address that as well. And I think that is a really great question. It's a great area to actually, I can't, as a chemist, we have fume hoods and it's a reason for them. With the positive pressure in a room, like it's actually supposed to suck everything out of it. So I think this is a really good ask. When we're talking about like local legislature or anything, we should have, that should actually have been in place when natural gas stoves existed. So now that we're doing hydrogen blending, we're like, we really should be pushing for the safety of our homes if we're if the natural gas industry is going to keep pushing their product. That's my point there. Ooh.
We actually have a question for you, Chris. Were the residents surprised at what you showed them in their kitchens?
Every single one of them, because you cannot see some of this. You can't see what we're seeing, with your eyes. So, I mean, people don't know what's happening. So the camera really shed some light or some gas in their life. It was scary. And I feel like, a lot of they learned a lot, and it's not much you can do when your house is already set up and it's not vented out. So I feel kind of bad delivering that. But yeah, there were absolutely every single person was surprised. Everyone. Yeah.
We also have someone asking if you can comment on the hydrogen hubs that were just massively funded by the Fed, such as the ones planned for Washington State.
I don't know if I can plan to comment too much on ones outside of Pennsylvania, because I haven't really been spending time on that research. I mean, obviously, everything in our presentation, we're talking about the first thing that we need to be looking at is what is this going to be used for? Because these are huge industrial processes. And if we're planning on using them for situations that are better to decarbonize other ways, then we are already barking down or heading down the wrong road. And there's a lot of, there are folks who are talking about the three S's, I believe. Oh, this is an
Mhm.
area that I need to do more research, but the use should be close to the infrastructure is one of them. Chris, do you remember the other two? I'm having
I
trouble.
I don't even know what the three S's, but I do know. I mean, a lot of us, just as the scientists in this organization, I am have been following the hydrogen hubs in a way, and of course we're seeing like DOE money, federal money, kind of being thrown out there without any understanding community wise as to what these hubs are actually doing, or what we don't have a clue. They call it out the community benefits aspect, but we've been kept out of the picture on for example, ours, which is the Mach 2, the Mid-Atlantic. They try to call it clean energy hub, which just makes me sick. But this is, I feel like, almost a beta test on the public. They don't know what they're doing. So as per the hydrogen hubs, they are not even a thing necessarily, like there's any infrastructure right now yet. It's an idea and a lot of money going into it. So, for me to say, the comments I would have for hydrogen hubs is that it was basically like research and development being done in public, in my opinion. It does come out of the DOE labs, which are research institutions, and so they have minimal understanding. And I mean, for example, hydrogen hubs are one beta test we see in Beaver. It's called the Safety Town, which is where I think it's Columbia Gas is actually doing like a mock town where they're actually already blending and trying out hydrogen blending in Beaver County, Pennsylvania. So again, that's using, like, in the public, they're doing research and development, which is kind of scary when you're dealing with such a dangerous substance or a material. So go ahead.
My mistake. It's the three pillars that people talk about: new supply, deliverability, and hourly matching. But I'm not going to go too deeply into that here.
Yeah.
There's a lot of great information online.
And each hub has been slated differently. Like Mach is pink, the color spectrum of everything. So I feel like there's another question to Linnea that kind of relates. If I could just probably address that. I think it was how much of the hydrogen proposed to be made in Pennsylvania is to come from methane. I can only speak to, we have ARC2, which, Ohio River Valley Institute has been doing some great work on that. And that's in the western side of Pennsylvania, to Ohio and West Virginia, I believe. Ours is Mach 2. Ours was proposed as pink, which is nuclear. And we just know one thing, that whatever the color is that they're playing with, it's hydrogen regardless. And when we know the industry has been funding this, how much is blue? Absolutely, I would say 100% this time. At least in Pennsylvania, a fracking state, there it is absolutely involved in at least the startup aspect of it, where they might have a goal to get to pink, but they have to start this process somehow. So out in ARC2, I believe they were probably utilizing more blue than the Mach 2 has been proposed to, which is supposedly pink.
All I've seen in Arch 2 is blue.
Yep.
Blue. I like to put blue in quotes because blue depends on carbon capture and sequestration, which is unproven technology.
Exactly.
It's sort of making a plan based on the possibility of something working well.
It's a theory.
Yeah, another question. Oh, sorry.
No, I was going to say Mach 2 is supposed to be pink, which is nuclear, green, as I've explained, and orange, which is from gas extracted from sewage, which is a whole other thing I can talk about with PGW, but that's long rabbit hole.
All right, your next question. Was the natural gas industry aware of the toxicity issue when gas stoves became common in homes?
Absolutely. As they've been aware of most things. They have a wonderful research and development, branches in their own companies, just like they knew about climate change. They've absolutely known about radioactive aspects of it. And so absolutely, they have definitely known and did not necessarily, they just put it in people's homes. And it's really our job as people to or scientists or the regulatory agencies, I would say, is to actually protect our health and safety. And it was just like put out as a great cooking. They went to like restaurants, you know, people love using natural gas versus like electric. You know, I have an induction, you know, stove. So yeah, it was absolutely known to say that, to say the least. But what really is frustrating is that, you know, I don't know how our regulatory agency, especially like the DOE, is pushing out hydrogen. Like they have research on it, and you know, without protecting, if you're going to put it in people's homes, you know, there should be. A lot of people don't like regulations, but there's some reasons for it, because people don't know, especially with, you know, natural gas or frack gas. You can't see it with your eyes, so you don't know if it's leaking. We put mercap in it because to have the odorant, so we know that if it's like, you know, not igniting or your pilot goes out, you smell the gas. There's an odorant in it. So, you know, as for like knowing it, yeah, they do know the explosive aspect. What we don't talk about, what they knew was also the toxic aspect of it, and the impacts to your health and safety. And there should have been at some point some talk about venting. Even restaurants have standards. Chemistry labs have standards about venting the volatiles out of your face. And it shouldn't be, you shouldn't be inhaling it. It shouldn't be anything. It's the same with our stoves. They absolutely knew.
Thank you. Last question. Are the utility agencies in California using a 2080 blend in their homes?
That was
No.
their highest on the experiment. Let me go back to like.
I would say no to that real quick. And by the way, 20% is a threshold because of, I think that's the max you can do with it. There's homes. So the California's case, as you're looking it up, I know there's one in Canada where one of the I think it was Enbridge maybe is actually blending in Canada in their own test bed, and they're only starting at 1%. If that, maybe they're up to 2 or 3%. I feel like the one in Beaver, Safety Town, actually proposed it as up to 20%, and we shouldn't be going anywhere near 20%, honestly. But a lot of other features that we've seen in like infrastructure that are doing routine maintenance, and they're like improving their stuff. They're putting in new like compressors and pipes that are actually able and rated to be at 20% blending. For example, Nicetown in Philadelphia, which is it's like a small generation plant, a gas generating plant, power generation. And they actually, if you look into their compressors and everything, the company touts how this compressor specifically is rated to be able to hold 20% hydrogen blending. So Linnea, if you found anything about California, I could answer the question.
Yeah, I'm trying to find the in the original presentation, the citation I used, but
nobody, by the way, this is the industry saying this, that people are not blending at 20% right now because it's quite dangerous. You start at 1%, 2%. So I do not know if anybody at
20%
this
is
time.
absolutely the highest. That's, and
You can't go
yeah,
any
it was
higher.
just California, but there are like in Europe, they're using much smaller amounts.
Was it in California that they are using 20?
They were testing it, yeah.
Ooh,
Let me see.
it's a dangerous thing.
Yeah.
Thank you. It doesn't look like we have any other questions. So I guess with that, we'll thank everyone for joining us. The recording will be available later, as well as the slides. And we also have a resource document with information about hydrogen blending that I will put the link to in the chat, should anyone be interested in downloading that. Otherwise, thank you for being here.
Thank you, everybody.
I can't guarantee that because I'm having trouble finding the citation, but here was a link to the Californian study, but I'm relatively certain that it was on a different page that I found it, but but this shows the CPUC project studying the impact up to 20%. So I know that in California they are like,
And they cannot go above 20% again because it's impossible to, like, without it being completely dangerous. So
and
that's why 20% is a number.
I don't think that's the right one, because what I used was what was a paper that was presented to the California Utility Commission. And I'm having some trouble finding that, but if anybody wants to follow up, I can certainly provide that. I'm just having trouble right now.
I will drop your info in the chat. All right. Thanks, everyone.
Great comments, everybody. Have a good day.